Hello and welcome to Soft Papers channel. My name is Godfrey. In this video, I'll be solving a Cambridge IGCSE chemistry paper, topical chemistry. Topic is acid, bases, and salts. This is a 2019 October-November exam series. I encourage you to consider using topical questions in your revision as you prepare for your forthcoming examination. This goes a long way in helping you master a given topic, read the notes and read the textbook on a given topic, and then come and attempt the questions that will be set on that topic for a period of years. You can start 2019, November 2019, June, going back to 2018, 2017, and so on and so forth. This way you'll be sure you have mastered the topic, and come exam, you'll be comfortable to do your thing. Before we continue, if you have not already subscribed to my channel, please click the subscribe button and hit the bell icon below. This way you will be notified every time I upload a new video. Let's get started. Number one, in all my papers, you'll find something like this. This tells you the exam variant from which this question was set. This question appeared in variant 1.1 and 2.1. It was number 16 in variant 1.1 and number 20 in variant 2.1 of October-November 2019 exam series. Of course, 0620, this is the exam code for chemistry IGCSE. So this tells you which paper the question we are solving was set in, and you can use this to be able to help you refer and also cross-check with the marking scheme if you so wish. So let's get started with this question. Multiple choice questions is per variant 1 and variant 2, then variant 3 and per variant 4. These are structured questions. We'll come to structured questions. Check out my for my videos on structured questions later. Number 1, carbonic acid is a weak acid formed when carbon dioxide dissolves in water. What is the pH of the solution? So there you are. Carbonic acid is formed when carbon dioxide dissolves in water, and it is a weak acid. What do you know about a weak acid? A weak acid is an acid that partially undergoes dissociates in solution. It undergoes partial dissociation, and therefore that's why it is referred to as a weak acid. Strong acid undergoes full dissociation, so that you have a cation and an ion separately. Now, what is the pH of weak acid? Of course, a pH of 1 is usually a strong acid. If an acid has got a pH of 1, this is a strong acid, right? A pH of 7 is neutral, and a pH of 9 is alkali solution. So basically that leaves a pH 5 to be the pH of solution of a weak acid. So the answer there is B. Number 2. Let's go to number 2. This question was set in variant 1.1. and it was number 17. If you so wish to cross-check. So solid X is tested as shown. Reaction with dilute aqueous sodium hydroxide, there's no reaction. Flame test, it's a red flame. Reaction with dilute hydrochloric acid, gas produced which turns lime water milky. And the gas that turns lime water milk, we all know it is carbon dioxide gas. right? And our flame tests, which gives us a red flame, we know that the compound is, or the metal is lithium. Lithium gives a flame test of, gives a red flame test. We are noticing that a reaction with dilute aqueous sodium hydroxide, there is no reaction. Therefore, basically, what you should be imagining solid X to be, because the question here is what is X. So X should be having a cation of lithium, and of course, since it is reacting with the dilute acid to give carbon dioxide, then this should be a carbonate. A solid X should be a carbonate, because carbonates are the ones which react with dilute acids to give us carbon dioxide. Therefore, you look for the multiple choice that has got lithium, and that should be B. So basically, lithium and lithium carbonate will react with hydrochloric acid. And just get and the equation here: lithium carbonate will react with hydrochloric acid, and this will give us lithium chloride. And carbon dioxide and water. Okay, so basically this is 2 and this is 2 right here. Of course, this is aqueous. This could be solid because you are told already solid X, and this would be aqueous, this would be gas, and this would be liquid. Okay, so that's the reaction that is happening with dilute hydrochloric acid. All the others are out because of the flame test here. Okay, all of them are carbonate, as you notice, with the exception of D, which is a sulfate. And the flame tests, we know it's lithium, and therefore that makes the others to be incorrect. So the answer right there is B. Number 3. Question number 3 is also from variant 1.1. Variant 1.1, and this was question number 18. Which oxide is basic? Which oxide is basic? Of course, we have two types of oxides. Types of oxide are 2 types of oxides. We only have 2: acidic and basic oxides. Now, acidic oxides formed from nonmetals and oxygen. Basic oxides are formed from metals and oxygen. Okay, so then of course, with that in mind, you can see for air, carbon is a nonmetal, therefore this is a basic oxide. Sodium is a metal, and therefore this is a basic oxide. Sulfur is a nonmetal, and of course water is formed when hydrogen, which is a nonmetal, bonds with oxygen. So the rest are nonmetals. Is only sodium oxide, which is sodium is a metal, and therefore this makes it sodium oxide, which of course I've got this formula to be the only basic oxide among the rest. So the answer right there is B. Number 4. Number 4 is a question that appeared in all the variants, 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, and it was either number 19 or number 21 in all the in each of the variants right there. So this is a question that appeared in all of the variants, as you can see. So it's a popular question for that matter. Let's look at the question itself. You're told a method used to make copper 2 sulfate crystals is shown. Number 1, place dilute sulfuric acid in a beaker, warm the acid, add copper 2 oxide until it is in excess. Excess means that until it reacts, all the sulfuric acid is reacted. Filter the mixture, evaporate the filtrate into crystals until crystals start to form. Leave the filtrate to cool. What are the purpose of step 4, step 3 and step 4? Step 3 is add copper 2 oxide until it is in excess, and step 4, filter the mixture. So when you look at the multiple choice, step 3, it is to ensure all the acid has reacted. That is correct. So both of those are correct. To speed up the reaction, this is step 4. There is no catalyst. So copper 2 oxide is not a catalyst, so it is neither speedy a reaction. When it comes to step 4, we are supposed to filter the mixture. The purpose of filtering the mixture is to get off the unreacted copper 2 sulfate, so that we only have a solution of what are we calling, because our interest here is to prepare copper 2 sulfate. So the solution that goes through the filter paper is a copper 2 sulfate solution. So is it to obtain solid copper 2 sulfate? Of course, the solid copper 2 sulfate will be left in the filter paper, but that is not our objective, because our objective it is to make copper 2 sulfate crystals. So the copper 2 sulfate crystals will be obtained when we crystallize the solution. So what is left in the filter paper is not copper 2 sulfate. What is left in the filter paper is copper oxide, which has not yet reacted, which did not react with sulfuric acid because it was in excess. So this is not correct. To remove the excess copper 2 sulfate, that is the right answer. Of course, to obtain solid copper 2 sulfate, that is not it. And of course that is also not correct. So the right answer here is B. Very good. You're watching this video on acids, salts and bases, but remember, I always encourage you to practice working out the questions yourself as I guide you through. You may get this same paper I am solving right now from this site here, which we're calling Soft Papers. The site is right here, Soft Papers. This is the site. You can go to this site here, softpapers.co.uk, and you'll get the same questions that I'm solving here, and we can solve them together. Of course, I can help you with bringing to you the site here. This is Soft Papers. This is the site I'm referring to. It's a very resourceful site. Get there. Of course, you can go to IGCSE. Chemistry is right there. You can get papers from 2020 to 2016, both past papers and topical. We are on topical, so go to 2019, topical, right here. There we will be brought to this page over here. Of course, you can get topical questions on November, both multiple and structured. Of course, there are some examples of soft topicals there. Then you can also get for June, and this happens to all the years, both 2019, 2018, going backwards. So these topical questions are available, and you only need to come here, click here to get all solved in a topical topicals in a zip folder. You'll be brought over here. You can get the topicals for 2019 November and also 2018, 2016 right there. Of course, the topicals in Z folders for structured. You can also get for both physics and chem if you're doing physics, and also for multiple choice. And then, of course, for June, right there. So you'll do good to request your parents to help you in accessing this content. It's fairly priced, only £9, and you'll be able to do that. Of course, you'll need to add it to a cart, and then, of course, go ahead and process the payment, and you'll be good to go. Very good, very well. You can proceed to question number 5. Question number 5 is set from variant 1-2, and this is question number 16. So, which statement describes the properties of hydrochloric acid? Which statement describes the properties of hydrochloric acid? Hydrochloric acid is, of course, you just ignore this. Hydrochloric acid is a mineral acid, is a strong acid. It undergoes total dissociation in solution. So let's look at the choices. Carbon dioxide is produced when limestone reacts with hydrochloric acid. I think that is correct, because when you react limestone is calcium carbonate. When you react calcium carbonate, a solid, with hydrochloric acid, HCl, of course in aqueous form, what you're going to be getting is a salt of calcium chloride. Of course, calcium chloride is soluble, so to form an aqueous solution, we'll have production of carbon dioxide gas, and water will be formed. So it says carbon dioxide is produced when limestone reacts with hydrochloric acid and carbon dioxide here, so that is correct. But let's look also on the other choices. Hydrogen is produced when sodium hydroxide reacts with hydrochloric acid. Now this does not seem to be correct, because this is a neutralization reaction. When a sodium hydroxide reacts with HCl, the products are only salt and water, which is sodium chloride plus water. So there is no hydrogen produced there, so this is not correct. Methyl orange turns yellow in strong hydrochloric acid. That is not it. It turns red in hydrochloric acid, does not turn yellow. A red litmus paper turns blue when dipped in hydrochloric acid. Likewise, this is not correct. Litmus paper turns red in acidic medium. So the right answer there is B. Question number 6. Question number 6 is from the same paper, variant 1-2, and this was question number 17. Okay, so a sample of X is heated with aqueous sodium hydroxide and a small piece of aluminium. A gas is produced which turns red litmus paper blue. The only gas that turns red litmus blue is ammonia. Ammonia is the only basic gas that is common in our laboratories. So when you see a gas turning red litmus blue, then you should understand that gas is ammonia gas. Now, aqueous sodium hydroxide solution is added to a second sample of X. A pale green precipitate is observed. A pale green precipitate is observed. And of course, from our chemical analytics, we know that a green precipitate is due to is due to ion 2 ions. Okay, that's notwithstanding, why do we need to use a small piece of aluminium? Small pieces of aluminium are required. Small pieces of aluminium are required, or is added when testing for nitrates. When testing for nitrates ions. Okay, so when you are testing for nitrate ions, you add a small piece of aluminium, and basically that converts the nitrates to ammonia gas, which turns red litmus paper blue. So an aluminium reacts with a nitrate ion in the presence of in an alkali medium. Of course, this will give us ammonia gas plus aluminium oxide ion. So this is the gas that will turn the red litmus paper blue. So basically, the next step is when sodium hydroxide reacts with ion 2 ions, what you get is an hydroxide of iron, which is insoluble. We only have 3 soluble hydroxide ions of metals: sodium, lithium, and potassium. The rest are insoluble. Of course, ammonia hydroxide is also soluble, but that is not a metal hydroxide. And then plus sodium here. Now this here is the green precipitate, PPT. And of course, this sodium ion here will combine with this aluminium oxide here, and then what you get is this. But our interest here is the ammonia and the hydrogen ions. I mean the ion 2 ions, and that basically gives us to know that sample X is ion 2 nitrates. Of course, you combine this and this to give you ion 2 nitrates. Ion 2 nitrates. Okay, this is 2. So the right answer there is C. Number 7. Number 7 is from the same variant 1, 2. And this was question number 18. Before we continue with number 7, I would like to welcome you to my online classes. I do online classes, tuitions. I've helped a lot of students in my classes, and they highly recommend my services. And we usually do this in a website called spacademy.co.uk. The site I'm talking about here is this one right here. SP Academy, basically Soft Papers Academy, and of course you can have a look at it, but I need you, if you are a student, I need you to check the student guide. Click here for a step-by-step guide for students dashboard functionalities, and you might also be interested in watching this video to get familiar with my online classes. So we offer ICT, mathematics, physics, biology, and chemistry in this site as tuitions. Of course, start from checkpoint all the way to Air 2. So I welcome you to try out my services. I need you to come here. Log in, and of course you need to register. Your student, choose a student. Provide the correct email, because you need. We'll send you an activation code which you need to activate to access the account that you have created. Of course, after you activate, you'll be direct to sign in. Of course, then you can come and check for find tutor of your choice as you so wish. I usually charge fairly. Of course, my charges quite fair. For one student, one-on-one, my charges are £35. But if you 3 or more for 4 students, this is per hour. If you have more students, of course, I give you a fair price of 25 per hour. So I welcome you to join me, and I'm sure we will have a good time learning chemistry together. All right. Hopefully I'll be seeing you in my classes shortly. So make effort and show up. I'll be grateful. Okay, number 7. Of course, it's from the same variant 1, 2, number 18. Which element forms an acidic oxide? As we mentioned in an earlier question, we say that acidic oxides are formed when a nonmetal bonds with oxygen. Of course, example here is carbon dioxide. This is an acidic oxide. Sulfur dioxide is also an acidic oxide. So which element forms an acidic oxide? So a nonmetal with oxygen. All these are metals: magnesium, lithium, calcium. These are metals, and these form basic oxides. So the answer there is D. Number 8. Number 8 is from variant 1-3, and this is question number 16. Which statement about dilute sulfuric acid are correct? It turns blue litmus paper blue. That is correct. It reacts with magnesium oxide to form magnesium 2 sulfate and water. Alright, this is not true. I was thinking it turns blue to red. This is not true. It turns blue litmus to red, not red to blue. So 1 is not correct. It reacts with magnesium oxide to form magnesium sulfate and water. Let's see. Magnesium oxide plus sulfuric acid. What do we get? We get magnesium sulfate plus water. Of course, that is true because magnesium oxide, this is a base, and bases with acid form a neutralizing reaction, give us salt and water only. So this is true. It reacts with magnesium to form magnesium sulfate and carbon dioxide. That is not true. Carbon dioxide is formed when we have a carbonate, but this is only magnesium. So you can also show how this forms. So when magnesium reacts with sulfuric acid, what we get is magnesium sulfate and oxygen. And hydrogen gas only. Right, so there's no carbon dioxide here, so that is not right. His pH is below 7. Yeah, all acids, pH of acid is from 1 to 6. Right, so below 7 is correct. So the right answer there is 2 and 4, and the correct choice is that for that question. Number 19. Question number 19 from variant 1-3. This was question number 17. X is a white powder. The following tests are done on X. No precipitate is seen when a few drops of sodium hydroxide are added to the solution of X. No precipitate is seen. Note that. No gas is formed when X is heated with aqueous sodium hydroxide, right? X gives a lilac color when put into a flame. The metal that gives a lilac color in flame test is potassium. Okay, so you can just know that. When acidified aqueous silver nitrate is added to a solution of X, a yellow precipitate is seen. So what is X? So of course lilac color basically tells us that should be potassium. So A and B are out because ammonium is not a metal. So the flame test is usually done on metals. So potassium should be the should give us a lilac flame. So it could be C or D. Then we know that of course you can put it here. Potassium, the chemical symbol for potassium is K. So potassium flame is lilac color, of course. So we know that. Then when potassium, because we have now potassium bromide and potassium iodide, when potassium bromide reacts with aqueous silver nitrate, what we get is potassium nitrate. All nitrate salts are soluble, so there is no precipitate there for potassium nitrate. This is aqueous. And what we get now is silver bromide. Now silver bromide is insoluble, so it is going to form as a precipitate, as a solid. And we also can look at potassium iodide. Potassium iodide plus silver nitrate will give us potassium nitrate plus silver iodide. Still, this is also a solid. It will be a yellow precipitate, and therefore this is the yellow PPT. For silver bromine, this is usually cream PPT. Therefore, the right answer should be iodide, potassium iodide. Number 10. 10 is from variant 1-3. This was question 18. Which three oxides are acidic? Acidic means that all oxides are non-metal oxides, right? These are non-metal oxides. So you look at A, there's a metal oxide here, so A is out. B, there's also calcium here, which is a metal, and there's also sodium there, which is a metal, which is out. And then of course D has also got sodium there, which is a metal. It's only C which is non-metal oxide, calcium oxide, sodium, nitrogen dioxide, and sulfur dioxide. Right answer C. Number 11. This is from 2-1 from extended paper. This was question number 19. Which statement about amphoteric oxide is correct? Now, amphoteric oxides are oxides that will react with both acid and alkali solutions. Okay, and the example of amphoteric oxides, e.g. of amphoteric oxides are basically aluminium oxide is amphoteric, zinc oxide is also amphoteric. Also we have lead oxide is also amphoteric, and therefore which statement is correct? They are meant by combining an acidic oxide with a basic oxide. That is not correct. That is not correct. they react with water to give a pH solution of 7. Still not correct. That is only when they react, amphoteric, when react with either an acid or a base, then they will give a pH of 7 because it is salt and water that you get, but not when they react with water. They don't react with water. They actually meant to dissolve in water, but that is not usually the case. They react with both acids and bases, and this is correct. Of course, I can give you an example here of aluminium oxide. It will react with HCl, and HCl is an acid. In this case now, aluminium oxide is behaving as a base, and what you get is a salt, aluminium chloride, and water. The same aluminium oxide will react now with a base, sodium hydroxide, and when that happens, we get a salt. We get this salt. This is 3. And water. So here, this is its behavior as an acid, but here the same is behavior as a base. Right. So in that case, they react with both acids and bases, and that is correct, to give us a salt and water. Of course, D is not correct. They do not react with bases, and so this is not correct. So the right answer there is answer C. Number 12 is from variant 2.1, and this was question number 22. Lead 2 sulfate is an insoluble salt. Of course, does not dissolve. I hope you know the other insoluble salts, like the chloride, silver halogen salts are insoluble. Silver chloride, silver bromide, silver iodine are insoluble. Barium chloride is also insoluble. And the other one is calcium what? There's another sort of calcium that is not calcium sulfate. So which process is not used to prepare a pure sample of this salt? Not used to prepare. Of course, for you to do crystallization is a process used to prepare crystals of soluble salt from saturated solution. So this process prepares soluble salts, prepares this is a process used to prepare crystals. Okay, crystallization, crystals of a soluble salt. So the salt, for you to get crystals, the salt should be soluble, and this is usually done from a saturated solution. Saturated solution is a solution that cannot dissolve more of a given solute at a certain temperature. So this is the only one that you cannot use to prepare a sample of an insoluble salt. The salt should be soluble for this. For you to do crystallization. Of course, dry is correct. Filtration and precipitation, those will be some of the steps that you need to do when you're doing preparation of insoluble salt. Number 13. Of course, this is from 2.2, variant 2.2, question number 19. Which oxide is classified as amphoteric? Of course, we have just looked at that in the previous question up there, so without hesitation, you know that is the one. As we say that we have aluminium oxide and zinc oxide as being amphoteric oxides. Number 14 from paper variant 2.2. This was question number 20. Which statement describes the properties of hydrochloric acid? Looks like this question we have met it previously. Carbon dioxide is produced when limestone reacts with hydrochloric acid. I think this is correct. Look above. We have met this question previously. You can confirm that. So we don't need to waste a lot of time on that. Question number 15. Lead. Of course, this was from variant 2.2, and this was question number 22. We are told that lead sulfate is an insoluble salt. Yeah. Which reaction produces a mixture from which lead to sulfate is obtained by filtration? So which reaction? So you have to, of this reaction listed here, you have to come with one which will give you lead sulfate. And when you do come up with lead sulfate, then it should be insoluble, and therefore you need to get it by filtration. Choice A, add the solid lead to carbonate to dilute sulfuric acid. So you can write the equation here. Lead carbonate, when you react it with sulfuric acid, what do you get? You get lead sulfate, which is insoluble. You get carbon dioxide, and you get water. All right. But remember, this salt is insoluble. So there are chances that when this salt forms, it will coat the lead carbonate from reacting with sulfuric acid further. So you should have that in mind. So let's look at the other choices. Adding solid lead to hydroxide to dilute sulfuric acid. All right. So lead hydroxide plus sulfuric acid. This will give us salt and water. The salt would be lead sulfate plus water, because this is an hydroxide and this is an acid. So we still have our lead here, which is solid. But do we obtain this one by filtration? We will see. Let's look at the other choices. Adding metallic lead to dilute sulfuric acid. Of course, when you react lead with sulfuric acid, here, what you get is a salt and hydrogen. So you get a salt called lead sulfate and hydrogen gas. So in this one, you don't need to do filtration, because hydrogen gas will escape, and all will be left with in this reactive vessel is lead sulfate. So you don't need filtration for C. What about for D? Adding aqueous lead nitrate to dilute sulfuric acid. Of course, when you react lead nitrate is soluble with sulfuric acid. What you get is lead sulfate plus nitric acid. Right there, this is solid. Okay, so basically here now you have to filter this to get your lead nitrate, and to get your lead sulfate and get your nitric acid to go through. So you separate these by filtration. So filter to separate lead sulfate, and sulfuric acid. Nitric acid. So this is the answer. Alright, you notice that in these other cases you don't actually need to filter anything, because carbon dioxide will just disappear. Then you'll be left with lead sulfate in some water, and of course same as this other one here. So the only one which you need to filter is this one, because which reaction produces a mixture from which lead sulfate is obtained. Lead sulfate and water, that's not a mixture. Alright, and lead sulfate and nitric acid, that's a mixture. So you need to filter that to get your lead sulfate. Very well. Number 16. Number 16 was from variant 2-3. This was question number 19. Which substance is a neutral oxide? A neutral oxide is an oxide that is neither acidic or basic. We already said that aluminium oxide is an amphoteric oxide, and carbon dioxide is a neutral oxide. Sulfur dioxide, this is acidic because it's made of non-metal. And zinc oxide, this is amphoteric. It is both acidic and basic. So the only neutral is carbon dioxide. It is neither acidic nor basic. Question number 17. Question 17. Which statement about dilute sulfuric acid are correct? It turns litmus blue. We've met this one earlier on. It's not correct. It reacts with magnesium oxide to form magnesium sulfide water. That's correct, because magnesium oxide is basic, sulfuric acid is an acid. Therefore, neutralization reaction will occur to get magnesium sulfide and water. Reacts with magnesium to form magnesium and carbon dioxide. No, it will form magnesium sulfide and hydrogen. pH is below 7. That's correct. So the answer there is C. Then question number 18. Question number 18. Lead iodide is formed as a precipitate in this reaction. Lead nitrate reacting with sodium iodide, aqueous. Both of them are aqueous. You get lead iodine solid and sodium nitrate, which is aqueous. Which method is used to separate the lead iodide from the mixture? Of course, that should be filtration. You'll filter to remain with the solid on the filter paper, then the nitrate will go through. This is a mixture. This is a mixture. Very good. Do we have question 19? No, this is the last question. So that's it, guys. Thanks for watching. Hope this has been helpful to you. I'll see you in my next video. Bye.